In the second question of the part on river routing, it is asked to determine the outflow hydrograph when a certain inflow hydrograph is given based on the k and the x values that are found in the first question. So we will apply again Muskingum, but as we know, we could actually calculate a qj plus 1 value, so an outflow value in the next time step, based on an equation a multiplied with the inflow value in time step j plus 1 plus b multiplied with the inflow value at the current time step plus c multiplied with the current value of the outflow. This current value of the outflow is known, or supposed to be known, as we calculate it step by step. For the initial value of the outflow value here, so the Q1, let's say, it will be taken to be equal to the inflow value. The coefficients A, B, and C are determined based on the equation of Muskingum and the equation of the conservation of mass, and are given below. And the particular thing about this is that A plus B plus C is equal to 1. Now, afterwards, when we calculate that, we will get an inflow value, an inflow hydrograph like this, and then an outflow hydrograph with our x equal to 0.12. And I've prepared the Excel sheet already, where we have our time, also already in seconds, our inflow values in cubic meters per second. We had our x value equal to 0.12, our k value equal to 7,200 seconds or 2 hours. So the flood propagation, the travel time of the flood wave will be 2 hours. And I have also copied the formulas for A, B, and C here in this Excel sheet. So based on our x and k value and our time step delta t, which will be 3,600 seconds in this case, we will calculate the A, the B, and the C value. So let's see, A, B, and C. A is equal to 3,600 minus 2 times K. That was the wrong button. So 2 times K multiplied with X, and this divided by 2 times K multiplied with 1 minus X plus 3,600. And we still need to close this bracket. That would be our A value. Let's make this a little bit cleaner. Like this. 3 digits is sufficient. Now, for the B term, I've copied the formula because it's almost similar. We will have 3,600, but instead of minus, we will have plus 2 times the K value multiplied with the X value, and then divided by the same term. And we also go to 3 digits. And then finally, we will use to start the same formula again. So, like this. But now we have the same denominator in this case, but it will be another numerator. So it will be 2 times K multiplied with 1 minus x minus 3600 will be this value. This a little bit cleaner. So we have a value for A, for B, and for C, which depend on x and k. Let's check if A plus B plus C is actually equal to 1. So A plus B plus C is indeed equal to 1. And now we will find our outflow values based on this formula, where we use our ij plus 1, ij, and qj. Like I mentioned before, we don't know the q value, so the outflow value at the first time step, so we will assume that this is equal to the first inflow value, as if it would be the value that is always present, something similar, let's say, to the base flow. It's of course a flood wave, so it's not really base flow, but you could see it in the same way. So to calculate qj plus 1, so q2 in this case, so j is equal to 1, we will take A multiplied with ij plus 1, I2 in this case, plus B multiplied with ij, so I1, plus C multiplied with qj, so q1. Let's make this a little bit cleaner already for all of the values. So let's keep 2 digits behind the decimal sign. Now, the remaining will be exactly the same. Let's have a look. Oh no, not exactly the same, because I forgot to fix some of these values. These should be fixed, of course, our A value, our B value, and our C value, and then we can drag like this. So it will be correct normally now. A multiplied with qj plus 1, B multiplied with qj, with ij, and C multiplied with qj. Let's have a look at one of the next. Here it's A multiplied with ij plus 1, B multiplied with ij, and C multiplied with qj. So that's correct. Let's make this a little bit cleaner, like this. And let's make a graph out of this. So we will have on our horizontal axis the time, and on our vertical axis the inflow and the outflow. Let's make a nice scatter plot out of this one. So we'll call it outflow Muskingum, like this. And let's add some titles. Horizontal axis will be the time in hours. The vertical axis will be, in general, flow in cubic meters per second, like that. And we see now that our inflow is attenuated when traveling along the river reach. So the maximum value of the inflow is higher than the maximum value of the outflow. And as we would expect for a river reach where we have a hysteresis, and we know that the Q max value comes after the S max value, where the inflow and the outflow values is equal, this is also correct. And actually, if we look at the maximum value here of our inflow, this will be around, let's say, 5 hours, sorry. And the maximum value of the outflow is at 7 hours, and that actually corresponds to our travel time of the flood wave of 2 hours. So that's also something that we see. And this is how we can calculate, based on the values of K and X that are determined, how we can calculate an outflow at a certain location, more downstream of the river reach, based on the inflow value that is given at the upstream part of the river reach.